Implants are needed in different types of situations, for instance, after an accident or because of a tumor. If the injury is very complicated, patient-specific implants are able to help. These types of implants are made with the help of a 3D printer at the Chair of Fluid Technology and Microfluidics at the University of Rostock. Generally speaking, additive manufacturing is the automated layer-upon-layer building of parts from 3D data. A model of the required implant is made based on CT or MRI datasets, but before it's imported into the printer, the model is manipulated. Screw access holes as well as vertical and horizontal channels are added. The implant is then sliced, meaning it's broken down into individual layers. These layers are then passed onto the machine. The machine, in this case a computer, then turns everything into machine code, sends it to the 3D printer, which in turn prints the respective information and creates the implant. Before the printing process, the storage container is filled with the material. The actual printing process takes place by repeating the steps of layer deposition, printing and lowering. The printing process takes place both on the print bed and the storage container. That means the extruder traces across the bed and then selectively prints the data it received from the layers into the actual powder bed. Once this layer has been printed, the print bed lowers one layer, approximately 1/4 millimeter. The cylinder retracts, the bed lifts up one layer, and a new layer is deposited. The extruder traces across the bed, once again selectively prints binder at the respective position, and the process continues like this successively. Our part is built by continually lowering it. The printing process can take several hours, depending on the size of the part. After printing is completed, the finished product still needs to be sintered, where it shrinks depending on the used material and ultimately achieves its final solidity. In our case, the sintering process is necessary because we only conglutinate our powder. This means the binder we use is actually a simple solution of sugar and water. If we remove the part at this stage, it's considered a so-called green shape. If we were to treat this green shape too harshly at this point, it would simply break since it's just fused powder. To achieve the ultimate strength of the implant, the green shape needs to undergo heat treatment. This is done in a so-called sintering oven. That means a specific sintering curve is observed, where specific temperatures are maintained for specific amounts of time. The material is heated in the sintering oven. This causes the fusion of the approximately 250 micron-sized spheres the powder consists of. You have two side-by-side sintered spheres. At 1275 degrees, they form so-called sintered neck structures, finally achieving solidity. That's why this is done here, because everything is just fused together and we need a specific final strength. The University of Rostock uses different materials for different processes. Next to titanium and thermoplastics, it also processes calcium phosphate in powder form. For patient-specific bone implants, we use calcium phosphate, or in our case, hydroxyl or tricalcium phosphate, because it combines the positive qualities of biocompatibility and resorption. That means we have powder with a corresponding fluidity. We can use it to print without any difficulty. We are also able to sinter it. We subsequently have our actual implant and know its exact characteristics. Research in the 3D printing sector is far from being completed. For example, it's still possible to speed up the printing process or construct a hybrid implant made of calcium phosphate and titanium. The ultimate success would be to create an exact replica of the bone. The bone is a highly complex structure. You have the hard outside and the spongy bone on the inside, and you need to ensure the inside is well supplied with blood and so on. I believe if you are ever able to replicate this in any way with the materials it involves, you have won the battle. Then that becomes the material of choice.